Okay guys, this is a video for further maths actually, for the first year's further maths that I'll be teaching next year. It's really weird actually making a video for people that don't know exist. I don't know if I'm ever going to teach them. I don't know anything. But I thought, let me make this as a good head start because the likelihood is I will be. So, first of all, what are we dealing with here? Let's go back to GCSE. When you are taught in GCSE, you are taught that quadratics could either have two solutions, one solution, or no solution. And if your teacher was particularly good, he would have added, or she would have added, the words over the reals. And he would have gone, okay, fine, I don't really care about any of that, square roots, blah, blah, blah. It's not an issue right now. Now, if you listen to Mark, Mark's one of our colleagues, and you're going to meet him, Mark will tell you that quadratics have always got two solutions. And I 98% agree with him. I disagree with him in one part. I think like if you've got two identical solutions, you've really got one solution. Let's say you're kind of splitting hairs there, but I'm sure there's some reason why he thinks he's always got two solutions. But the thing you should be coming at me with is like, okay, fine. What happens if it's a square root and you've got a negative number and you're doing quadratic formula, and then you have supposedly no solutions? Well, we have a little dodge around that, and we call that imaginary numbers. We say that the square root of minus one is called I. We're giving it that name. So that's a definition. It's our choice. So square root of minus 1 is I, square root of minus 16, as you can see, is 4i. Why square root of 16 is 4, square root of minus 1 is I. Why do we do such a thing? Because it's useful, right? And like, you might come back again at me and say, like, fine, we don't really care whether it's useful or not. If it doesn't exist, you can't have it. But then, like, that same argument comes back to negative numbers as well, right? What is minus 3 sheep if you are counting sheep? I don't know where the hell sheep comes from. I'm not Welsh. I don't know why that came into my mind. But minus 3 anything. Like, numbers come from counting, right? Okay, like we're getting some serious philosophy here. That's not quite true, but for most people that will do, yeah? Numbers come from counting. I have 2 pencils. I have 3 chocolate buttons. I have whatever. How does minus 2 even exist as a thing? If you haven't got a thing, it's zero, right? You can't have an absence of it. Don't come at me with temperature because that's arbitrary, right? We chose to put zero where zero is, right? If you use kelvins, there are no negative temperatures. Negative numbers don't exist. They can be useful though, potentially. Now, like as I said, that's kind of a huge simplification, but like it shows you that in mathematics you have been quite comfortable and have been for about 6 or 7 years, like messing with things you don't really understand and probably don't exist as a thing, right? If you actually do want to talk to me about like, philosophy of maths, please do come and find me because like it's something I studied a lot at university. I put it this way, I don't even believe numbers exist, let alone any of the rest. Like Greg's also another good person for this. He's slightly different views to mine. I'm a bit more radical skeptic than he is. Anyways, I digress. So we're calling square roots of negative one I. How can we use this? One quick example here. We've got a quadratic. This is kind of quadratic you wouldn't be able to solve at GCSE. You'd say no solutions. We run through the formula as before, but instead of stopping when it says square root of minus 5 and throwing up our hands saying, no, you cannot do this thing, we go, okay, square root of minus 5 is root 5 I. There's a little arrow saying complex conjugates, and that's the next thing I'm covering. So in the next video, you're going to find out a little bit more about complex numbers. You'll be finding out how you can draw them on graphs, and you can find out about complex conjugates. I hope that's a reasonably kind of robust explanation of what's going on here. Basically, the big takeaway from this is the square roots of negative numbers now exist. We can play with them, and we use I to denote them, and they work the way you'd expect them to. Square root of minus 1 is I, and if you've got a number in front of that, square root that number to get a coefficient. That's all.